A small plane can fly 420 miles with a headwind in 3.5 hours. It makes the return trip with a tailwind in 3 hours. Find the rate of the plane in still air and the rate of the wind. So there are two unknowns in this problem. The rate of the plane in still air and the rate of the wind. So I'm going to introduce two variables. I'm going to say let x represent the rate of the plane in still air, and I'm going to let y represent the rate of the wind. Now, this problem involves distance, rates, and we should make a note that these rates are in miles per hour. And times. So hopefully you're aware that those three ideas can be related with the formula. Distance is equal to rate times time. So we're actually going to create two equations involving distance, rate, and time. Okay, so the first equation is going to be with the headwind. All right, so with the headwind, the plane travels 420 miles, and that's equal to rate times time. Now, since it's a headwind, remember a headwind, it decreases your speed. You're going against the wind. So with the headwind, the total rate would be x minus y, the rate of the plane, and we would subtract the rate of the wind since it's a headwind. The amount of time was 3.5 hours. With the tailwind, the distance is the same. It makes a return trip. The distance is the same. But since there's a tailwind, remember the tailwind helps the plane. And so that would then be an x plus y would be the total rate, and they can make the return trip in 3 hours. So here is a system of equations that we can use. Now, you might be inclined to distribute that 3.5 in 3. And there's nothing wrong with that. You could do that. But I'm going to do something else instead. I'm going to take that first equation, I'm going to divide by 3.5, both sides of this equation. And if I do that, 420 divided by 3.5 is 120. So I get the equation 120 is equal to x minus y. And similarly, for the second equation, I'm going to divide by 3. And that gives me equivalently 140 is equal to x plus y. And now I can easily isolate one of the variables in one of the equations and make a substitution. So I'm going to add y to both sides of the first equation, and that will give me equivalently 120 plus y is equal to x. And so I'll make a substitution for x in the second equation, and that would give me equivalently 140 is equal to 120 plus y plus y. So then 140 is equal to 120 plus 2y. I'll subtract the 120 from both sides. 20 is equal to 2y. And dividing through by 2, we find that y is equal to 10. So we now know that the rate of the wind is 10. And remember earlier, we said that x was equal to 120 plus y. All right, that's what we used right here. So then x would equal 120 plus 10, and x is equal to 130. So conclusion. I'm not going to write an ordered pair here because this is, some realistic concepts. I'm just going to write a sentence as the solution. The rate of the plane in still air is 130 miles per hour, and the rate of the wind is 10 miles per hour.